clay feels cool against your fingertips, even through the archival gloves. The Ashmolean Museum in Oxford keeps its temperature controlled, precise, the kind of environment that preserves fragments of the world that existed before our world began. The object before you weighs perhaps 2 kilograms, four-sided, a prism of terracotta. Its surface is covered in wedge-shaped impressions so small you need magnification to read them properly. This is WB444, the Weld Blundell prism, and it contains something that shouldn't exist, a chronology that creates gaps in human history science struggles to explain. The tablet was excavated in 1922 from the ruins of ancient Lhasa in southern Iraq, though the text itself is far older. It lists the kings of Sumer, one after another in careful sequence, city by city, ruler by ruler, reign by reign. For the historical kings, the ones we can verify through archaeology, through building inscriptions, through administrative records, the numbers make sense. Gilgamesh of Uruk, 26 years, long perhaps, but within the realm of symbolic or kendrical interpretation. But then the text does something extraordinary. It divides history at a specific point. It says quite plainly, then the flood swept over. Before that line, the numbers become impossible. 8 kings, 5 cities, a total of 2,400 years. Alulim of Eridu ruled for 28,800 years. Alalia, his successor, 36,000 years. The text continues in this manner matter-of-fact, making no apologies, offering no explanations. These are not myths written as myths. They are presented as administrative records, as history, as the chronology upon which everything else depends. And here is what makes them problematic for conventional understanding. The Sumerians themselves treated these lists as factual documentation. They copied them, they preserved them, they built their understanding of kingship and legitimacy upon them. The text reveals a gap not in what the Sumerians didn't know, but in what we cannot reconcile. Before that flood, before that division in the text, lies a span of time that contains something our models of human development cannot accommodate. And the Sumerians knew it was there. They recorded it, they measured it, they insisted upon it. This is not a video about proving ancient astronauts or validating conspiracy theories. This is an investigation into what the tablets actually say, what they claim to preserve, and why the gaps they create in our understanding of history remain unexplained. The Sumerians left us records that suggest they were not the beginning of civilization, but perhaps its restoration, that the knowledge they possessed, complete writing systems, sophisticated mathematics, advanced astronomy, complex law codes, might not have been invented by them, but inherited across a catastrophe they took great care to document. If you're listening from somewhere quiet, somewhere you can settle into this investigation, leave a comment about where you are and what time it is. This will take us deep into clay and chronology, into temples and time, into the question of whether humanity's story is one of steady progress or whether it contains chapters we've forgotten how to read. The flood swept over. Then kingship descended again. But what knowledge descended with it? And from where? The architecture of memory. When archaeologists first excavated the Great Mound of Uruk in southern Iraq, the city that gives its name to an entire period of Mesopotamian history, they found something that troubled them. The city appeared suddenly around 4000 BCE, not as a village that gradually grew into an urban centre, but as a fully formed metropolis covering over 6 square km. It had monumental architecture, massive temple complexes, administrative centres with standardised systems of accounting, and everywhere on thousands of clay tablets, a writing system that was not crude or experimental, but sophisticated enough to record both simple inventories and complex legal concepts. The problem was simple. There were no rough drafts, no practice runs, no visible stages of development where a society learns slowly and painfully to organise itself at this scale. The Uruk period appears in the archaeological record with its systems essentially complete. Conventional scholarship explains this as rapid development building upon the earlier Ubide period, a time spanning roughly 5900 to 4000 BCE, when villages dotted the Mesopotamian landscape, producing distinctive pottery and establishing agricultural systems. But the transition from Ubaid villages to Uruk cities represents more than growth. It represents a fundamental transformation in human organization that happened, archaeologically speaking, almost overnight. Consider what appears simultaneously in Urukea form writing in its proto-iterate form, capable of recording not just quantities but abstract concepts. Complex irrigation systems requiring centralized panning and maintenance, monumental religious architecture built to standardized measurements, cylinder seals for marking property and authority, a base, 60 mathematical systems still used today for measuring time and angles, astronomical observations requiring instruments and long-term record-keeping, standardized weights and measures for trade, metal tools requiring specialized knowledge of smelting temperatures and alloy ratios. Each of these developments, conventional theory suggests, should require generations of experimentation. Writing systems don't appear complete. They evolve from pictographs to ideograms to phonetic scripts over centuries of refinement. Yet in Uruk, within archaeological layers spanning perhaps 2 or 3 generations, we find accounting tablets that already employ sophisticated grammatical particles and abstract numerical concepts. The temples trouble us further. At Eridu, the city the Sumerians themselves identified as the oldest settlement in the world. Excavations by Satan Lloyd and Fuad Safire in the 1940s revealed something remarkable. 18 temple structures built one directly atop another spanning thousands of years. The lowest temple, designated Temple 1, dates to approximately 5400 BCE, deep in the Ubaid period. It consists of a small room roughly 3 1/2 ms square with an offering table and an altar niche. Temple X8, the latest in the sequence, is a massive structure with elaborate buttresses, decorative niches, an altar platform, and an offering table positioned precisely along the central axis. Between Temple 1 and Temple 17 lie 16 other structures, each slightly larger, each more architecturally sophisticated, each built directly over its predecessor according to a plan that maintains exact orientation and central axis alignment across more than 2,000 years of construction. Here is what this sequence suggests. The builders of Temple Y already understood that they were establishing something meant to endure. The position was sacred, the orientation was fixed, and every subsequent generation understood they were maintaining, not creating, the sacred architecture. The temple grew, but it grew according to principles already present in that first small room from 5400 BCE. What knowledge system allows a Neolithic village to establish architectural principles that will guide urban temple construction for 3 millennia? How do farmers in 5400 BCE understand sacred geometry and astronomical alignments that urban civilizations in 3000 BCE will inherit and expand? The temples at Eridu are not learning to be sacred spaces. They already know what they are from the beginning. They simply grow larger, more elaborate, but never deviate from the foundational principles. The Sumerians themselves had an explanation for this. They recorded it carefully on their cylinders and tablets. They said that Eridu was the first city where kingship first descended from heaven before the flood. They said that Enki, the god of wisdom, fresh water and crafts, dwelt in the Abzu, the freshwater abyss beneath the temple, and that he gave the Mi to humanity. The Mi are difficult to translate directly. They are divine principles, arts, civilizing powers. The word encompasses everything from writing and mathematics to kingship and law to music and metalwork. They are in essence the complete package of civilization itself. Modern scholarship treats this as mythology, as a culture creating origin stories to explain itself. But notice the specific claim. Civilization is not invented by humans. It is given. It descends. It is transferred from a source that predates the cities we can excavate. When we examine what appears in the Euro period, we find not innovation, but application, not invention, but deployment of knowledge that somehow already exists in complete form. The mathematics is not developing, it is being used. The writing is not being experimented with, it is recording complex transactions. The architecture is not learning to create sacred space, it is building in accordance with principles established centuries earlier. This is the architecture of memory, systems built to preserve what came before, cities constructed according to templates that precede them, knowledge deployed rather than discovered. And at the center of it all, the Sumerian insistence that what they possessed was given to them, taught them before the flood swept over and then restored when kingship descended once more. The gap we face is not what the Sumerians didn't develop. It is what they possessed without apparent development, knowledge complete at its first appearance, systems sophisticated from their earliest use, and a culture that consistently claimed they received this knowledge rather than invented it. The temple at Eridu remembers itself layer by layer, century by century. It maintains principles established before cities existed. This is not progress, this is preservation. And it suggests that what we call the beginning of civilization might be something else entirely, the restoration of something that existed before across a gap in time. The tablets carefully mark, but we struggle to explain. When kingship descended from heaven, the Weld-Blondel prism is not the only version of the Sumerian King List. At least 16 fragmentary copies exist scattered across museum collections in Philadelphia, Oxford, Berkeley, Istanbul, and Baghdad. Each version shows slight variations in names, numbers, city sequences, the kind of variations that occur when scribes copy and recopy text over centuries. But every version maintains the same fundamental structure, a division of history at the flood. And before that division, a sequence of kings whose reign lengths defy conventional chronology. The text begins with certainty. After the kingship descended from heaven, the kingship was in Eridu, not arose, not developed, descended from heaven to Eridu specifically, the oldest city, the first city, the place where Templar 1 was built in 5400 BCE. In Eridu, Aluluim became king. He ruled for 28,800 years. Then Alajar ruled for 36,000 years. The text lists these numbers without commentary, without apology, as straightforward chronology. The kingship moved to Bad Tabira. Enmanlu Anna ruled for 43,200 years. Ennala ruled for 28,800 years. The god Dunuzid, described as a shepherd, ruled for 36,000 years. 5 cities, 8 kings, 2 for 1,200 years total before the flood. Then the text states, then the flood swept over. After the flood, kingship descended from heaven once more, this time to Kish. The reign lengths after the flood are still long by historical standards. Gao ruled Kish for 1,200 years. Galanidaba Anipad for 960 years, but they decreased generation by generation until by the time we reach the first dynasty of Uruk, the numbers approach something historians can work with. Gilgamesh's 126 years is still symbolic or legendary, but it's within the range where we can imagine it as a real ruler's lifetime exaggerated through oral tradition. The structure is deliberate. The text marks a clear boundary at the flood. Before impossibly long reigns, after gradually normalizing chronology, the flood is not incidental to the list. It is the pivot point, the division, the event that separates one kind of history from another. Mainstream scholarship approaches this as mythology dressed in historiographic form. The antediluvian kings are understood as legendary figures, their reign lengths symbolic of a mythic golden age before civilization began. The flood represents a cultural memory of regional flooding in Mesopotamia, perhaps the inundation events archaeologists have identified in the layers of Sumerian cities. The post-Diluvian kings gradually become historical figures as we move closer to periods where we have independent verification of rulers through building inscriptions and administrative records. This reading is reasonable. It aligns with how other ancient cultures used king lists as ways of establishing legitimacy, connecting present rulers to divine or legendary origins, creating a sense of continuity and authority. The Egyptians did this, the Greeks did this, every ancient civilization used genealogies that blended history and legend. But here is what this reading must explain away. The Sumerians had practical arithmetic. They could calculate areas for field surveys. They could divide inheritances. They could track lunar months and solar years. They understood the difference between symbolic numbers and practical measurements. Their administrative tablets show clear, literal accounting. 3 sheep, 14 jars of barley, 6 copper tools. They were not innumerate or incapable of realistic chronology. Yet when they created the document that served as the foundation for understanding their own history, for establishing which rulers were legitimate and which were not, they began it with 2,400 years of reigns before a flood, followed by gradually decreasing reigns after that flood. And they maintained this structure across centuries of copying and recopying. Every scribe who encountered these numbers preserved them. Every scholar who studied the list accepted them as part of the historical record. What if the numbers are not symbolic? What if they are not metaphorical expressions of a mythic age? What if they represent an actual chronological problem the Sumerians themselves faced? A gap in history they knew existed but could not explain except by recording what their sources told them. Consider the possibility this way. The Sumerians are receiving their history from texts, monuments, and traditions that predate their own literate period. They are inheriting a chronology. When they try to make sense of how much time passed before the flood, their sources give them numbers that seem impossible. But the sources are consistent. Multiple texts agree. The traditions align, so they record what they have. Knowing it creates a problem, but unable to resolve that problem without discarding the sources they consider authoritative. The Eridu Genesis tablet, catalogue number CBS 1063 in the University of Pennsylvania Museum, provides additional context. This tablet, excavated from Nippur in the late 19th century, dates to approximately 1600 BCE, but records a far older Sumerian composition. It describes the creation of humanity, the establishment of cities, and the sending of the flood. The text is fragmentary, roughly 2/3 is missing, but what survives describes kingship being lowered from heaven to 5 cities, then the flood, then the survival of Zudra in a boat, then the restoration of civilization after the waters recede. The structure matches the king list: cities established, kingship functioning, flood occurring, restoration following. The Eridu Genesis treats this as historical sequence, not allegory. It describes the god Enki warning Ziusudra about the coming flood, instructing him to preserve life in a boat. After the flood, Judra receives eternal life and is settled in Dilma. Kingship returns to the earth. Cities are rebuilt. Multiple Sumerian texts present this same pattern. Civilization before flood, catastrophe, survival, restoration. They do not present this as happening once upon a time in a land far away. They present it as their history. The flood happened here in these cities to these kings. The restoration happened here to our ancestors. This is not mythology about other people. This is historical memory about us. The chronological gap the king list creates is this. If kingship functioned in Eridu, Badibira, Larak, Sippar, and Shuruppak before the flood, then civilization existed before the flood. If the reigns total 2,400 years, then either that number is symbolic, but why that specific number, or it represents time scaled in a way we don't understand, but scaled by what factor and according to what system, or it records a chronology that involves gaps, overlaps, or spans that extend far beyond what archaeology currently permits for human civilization. The Sumerian solution to this problem is straightforward. They record what their sources tell them and let the numbers stand. They mark the flood as the boundary event. They show the gradual normalization of chronology afterward. They preserve the text for 3,000 years. Our solution is to dismiss the numbers as legendary, but that dismissal requires us to believe that the Sumerians who could calculate the area of irregular fields and predict lunar eclipses, who standardized measurements across city-states and maintained meticulous administrative records, somehow lost all mathematical sense when recording the foundation of their own political system. Or it requires us to accept that they inherited a chronology that created a gap they could not resolve, that their sources told them kingship functioned for vast spans of time before a catastrophic flood, and that after that flood civilization was restored, not invented, not slowly developed, but restored with its systems largely intact. The text says kingship descended from heaven twice, once before the flood, once after, not arose, not emerged, descended. given transferred from a source above or before or outside the normal development of human culture. The tablets reveal the gap, the flood marks the gap, and when civilization appears again, it appears complete with writing and mathematics and astronomy and law already formed, as though the gap were not a loss but an interruption in transmission, as though what came after the flood was not beginning but continuation. Science cannot yet explain this gap. Not the chronological chasm the King List creates, not the sudden appearance of complex systems without developmental stages, not the Sumerian insistence that they received rather than invented. The tablets leave the question open. The flood swept over, then kingship descended once more. But from where and with what knowledge? The tablets that remember the deluge. The British Museum holds fragments of a text known as the Atraus epic, tablets inscribed in Adian uniform dating to approximately 1700 BCE, but recording a story far older, originally Sumerian. The epic tells the creation of humans, their multiplication across the earth, the gods' decision to destroy them through flood, the survival of the wise man Atrasis, and the restoration of humanity afterward. But unlike later flood narratives that focus on moral judgment, the Atrahasis epic contains a specific detail that matters for understanding knowledge transmission. Before the flood comes, Atrasis is instructed to preserve not just life, but the foundations of civilization itself. The god Enki warns Atrasis about the coming deluge. He tells him to build a boat, to seal it with bitumen, to bring aboard his family, animals, craftsmen, and seeds. But the text includes another instruction often overlooked in popular retellings. Atrasis is to preserve the knowledge of crafts, the techniques of survival, the wisdom necessary to rebuild after the catastrophe passes. The epic describes the flood in vivid detail, 7 days and nights of rain, the earth covered in water, the gods themselves terrified by the destruction they've unleashed. Then the waters recede. Atrahasis opens the boat. He makes offerings. The gods smell the sweet savor and gather around the sacrifice. Realizing they have nearly destroyed the labor force that feeds them through offerings and temple service, they agree to preserve humanity to allow civilization to continue, but with certain restrictions to prevent overpopulation and the noise that originally disturbed them. Here is the pattern embedded in the text. Civilization exists before the flood. It is sophisticated enough to include craftsmen, specialized knowledge, agricultural techniques, organized worship. The flood interrupts but does not erase this civilization. Knowledge is preserved deliberately through the survival of specific people who carry it forward. After the flood, civilization resumes, not restarting from zero, but continuing from a preserved foundation. The Erasure Genesis presents the same structure with Zusudra as the protagonist. The instructions of Shirupak tablets excavated from Abu Salabik and dating to around 2600 BCE contain something even more specific, a wisdom text attributed to Shirupak, the last antediluvian city in the Sumerian King List. The text consists of a father Shirupak giving advice to his son Zusudra, the same Zudra who will survive the flood. The instructions are practical. Do not buy a donkey which brays too much. It will split your midriff. Do not vouch for someone. That man will hold it against you. Do not pass judgment when you drink beer. These are not mystical revelations. They are the accumulated wisdom of generations. Agricultural advice, social guidelines, warnings about lending and borrowing, instructions for maintaining relationships and reputation. But the frame is crucial. This wisdom is being transmitted from Shirupak to Zusudra before the flood. Wisdom from the antediluvian world carried across the catastrophe by the flood survivor, preserved in tablet form by the Sumerians. The instructions of Shirupak are not just any wisdom text. They are explicitly pre-flood knowledge, maintained and copied for over 1,000 years by scribes who understood they were preserving something from before the boundary event that divided history. Multiple Mesopotamian texts present flood narratives: the Sumerian Erasure Genesis, the Akkadian Atrahasis epic, the flood episode in Tablet Emth of the Gilgamesh epic. Each version contains variations in detail, but all maintain the same structural elements: warning from a god, construction of a boat, preservation of life, catastrophic flood, survival, restoration, covenant with the gods. This is not evidence that the stories are simply copying each other. This is evidence of a persistent cultural memory maintained across languages and centuries of an actual catastrophe that served as a historical boundary marker. Archaeology provides context. Excavations multiple Sumerian cities, Uruk, Shuruppak, Kish, have identified flood layers in the stratigraphic sequence. These are not mythological floods. They are real deposits of water-laid clay interrupting the normal occupation layers. The archaeologist Leonard Woolley famously identified an 8 ft thick layer of clean clay devoid of artifacts separating earlier occupation layers from later ones. He initially believed this was evidence of the biblical flood. Later analysis showed it was likely a localized river flooding event significant for but not global. Yet the flood layers exist. Multiple cities experienced catastrophic inundations at various points in the 4th and 3rd millennia BCE. For cultures living in the flat alluvial plain of Mesopotamia, where rivers flood unpredictably and can change course without warning, these events would have been civilization destroying on a regional scale, cities abandoned, populations displaced, knowledge systems interrupted. What matters for understanding the Sumerian tablets is not whether the flood was global or local, but that it functioned as a historical boundary. Before flood, antediluvian civilization, impossibly long reigns, knowledge established. After flood, restoration, gradual return to normality, re-establishment of cities and kingship. The flood marks a gap in chronology, a gap in transmission, a gap that must be crossed for knowledge to continue. The tablet narratives consistently present the crossing of this gap as deliberate preservation. Atrahasis preserves craftsmen. Zu-Sudra receives wisdom from his father Shuruppak. Enki ensures the survival of the me, the principles of civilization. The flood is not the end of knowledge. It is the test of whether knowledge can be transmitted across catastrophe. When civilization resumes after the flood in the king list, it does not start over. Kingship descends again, but it descends to cities that rebuild according to prior patterns. The temple at Eridu is reconstructed on the same sacred spot. The cuneiform writing system appears without a visible learning curve. The mathematics function with base 60 sophistication. The astronomical observations continue tracking cycles that require generations of accumulated data. This is the pattern of preservation, not innovation. Restoration, not invention. Knowledge maintained across a gap by deliberate transmission. Modern science struggles with this pattern because our models of civilizational development assume continuous progress. Villages become towns. Towns become cities. Cities develop specialization. Specialization produces knowledge. Knowledge accumulates gradually through experimentation and refinement. Catastrophes can destroy civilization, but the knowledge must be rebuilt from first principles afterward. Relearning agriculture, rediscovering metal, reinventing writing. But the Sumerian tablets present a different model. Knowledge exists. Catastrophe occurs. Knowledge is preserved by a remnant. Civilization restores itself using the preserved foundation. The flood does not destroy the knowledge, it interrupts its transmission. The gap is not permanent, the continuity resumes. If this model is accurate, then what we see appearing in the Uruk period is not invention, but deployment, not discovery, but application of knowledge that survived across the boundary event. The tablets that remember the deluge are not recording mythology. They are documenting the process by which civilization maintained itself through catastrophe. The instructions of Shuruppak end with a phrase that appears in multiple copies. Praise be to Nisava, the goddess of writing, grain, and wisdom. The text preserves pre-flood knowledge, crosses the boundary into the historical period, and praises the goddess who ensures that writing. The technology that allows knowledge to persist across time continues to function. The tablets remember because remembering is their purpose. They are not literature, they are not entertainment. They are preservation technology designed to carry knowledge across gaps that would otherwise erase it. The flood swept over, but the tablets, once baked hard by fire or buried in the ruins of libraries, survive. And what survives tells us there was knowledge before. It was preserved, it was restored, and the civilization we call the beginning might be continuation instead. The mathematics that appeared complete in 1945. The mathematician Otto Nojibau published Mathematical Ununiform Texts, a study of Babylonian mathematical tablets that fundamentally changed how historians understood ancient mathematics. Among the tablets he analyzed was Plimpton 32, a clay tablet held in the collection of Columbia University's Rare Book and Manuscript Library. The tablet measures approximately 13 by 9 centimeters, is broken on the left side, and contains 4 columns of numbers written in ununiform script. Plimpton 32 dates to approximately 1800 BCE from the Old Babylonian period. It was excavated from Lhasa in southern Iraq, sometime in the early 20th century before strict archaeological provenance standards existed. Purchased by the American archaeologist and publisher George Arthur Plimpton, and eventually donated to Columbia after his death. The numbers on the tablet are organized in columns. The rightmost column numbers the rows from 1 to 15. The second column from the right contains numbers that scholars eventually recognized as the short sides of right triangles. The third column contains the hypotenuses of those triangles. The leftmost column, when scholars finally understood what they were seeing, contains the squares of the ratios between the long side and the hypotenuse. This is not simple arithmetic. This is sophisticated trigonometry, organized in tabular form, calculating relationships within right triangles using what we now call Pythagorean triples, sets of 3 whole numbers that satisfy the equation a plus bu cu. The tablet demonstrates understanding of geometric relationships that conventional history claims were not formalized until Greek mathematicians, particularly Pythagoras, worked them out around 500 BCE. Plimpton 32 predates Pythagoras by 1300 years. The tablet is not explaining the mathematics. It is not teaching the relationships. It is applying them, using them as a tool for some practical purpose. Scholars still debate perhaps surveying, perhaps engineering, perhaps architectural planning, perhaps scribal education in handling complex numbers. Whatever the purpose, the mathematics is already complete. The relationships are known, the system functions, and this is not the only mathematical tablet from old Babylonian Mesopotamia. Dozens of tablets demonstrate sophisticated problem solve, calculating the area of irregular fields, determining fair division of property, solving what we would call quadratic equations, working with geometric progressions, understanding place-value notation. The mathematics is not primitive. It is elegant, efficient, and fully functional. But here is the problem. We have almost no evidence of how they developed this mathematics. No practice tablets showing trial and error, no texts explaining the discovery process, no records of mathematical breakthroughs or debates about which methods work best. The mathematics appears in the tablets already formed, already standardized, already being applied to real-world problems. Consider the sexagesimal system base. The Sumerians counted in groups of 60 rather than 10. This choice seems arbitrary until you examine its properties. 60 is divisible by 1, 2, 3, 4, 5, 6, 10, 12, 15, 20, and 30. This makes fractional calculations remarkably simple. Dividing something into thirds, quarters, fifths, or sixths produces clean numbers without the messy decimals that plague base 10 systems. We still use base 60 mathematics today. 60 seconds in a minute, 60 minutes in an hour, 360 degree, 60 in a circle. These are not arbitrary conventions. They are Sumerian mathematical choices that proved so useful they persisted for 5,000 years across every subsequent civilization that encountered them. But why would a culture developing mathematics for the first time choose base 60? Base 10 is intuitive. We have 10 fingers. Base 20 makes sense. Add the toes. Base 5 is simple. One hand. Base 60 requires recognizing advanced divisibility properties that aren't obvious until you've already done extensive mathematical work. The Sumerians didn't start with base 10 and eventually recognized base 60's advantages. The earliest Sumerian numerical tablets already use base 60. The system appears complete at the beginning of written records. This suggests either that the Sumerians spent considerable time, perhaps centuries, developing the system before they began writing it down, or that they inherited the system from a prior source. The measurement systems show similar sophistication. The Sumerians used standardized units for length, area, volume, and weight that remained consistent across cities and centuries. The basic unit of length was the ninden, approximately 6 meters, divided into 12 shu-si digits, about 50 centimeters each. The basic unit of area was the sayar, roughly 36 square meters. The basic unit of volume was the selah, approximately 1 liter. The basic unit of weight was the shekel, about 8.3 dri. These units don't appear in any obvious way from natural measurements like the length of a foot or the distance an ox can plough in a day. They are abstract standards requiring centralized authority to enforce and mathematical sophistication to apply. Yet they appear fully formed in the earliest Sumerian city-states. Every surveyor uses the same ninden, every merchant uses the same shekel, every accountant uses the same selah. Who standardized these measurements? When? How did every city agree to use identical systems? The tablets don't tell us. They simply use the standards as though they had always existed. The mathematical tablets from Nippur excavated by the University of Pennsylvania in the late 19th and early 20th centuries include student exercises from the Edinburgh scribal schools. These tablets show young scribes practicing calculations, copying multiplication tables, working through surveying problems. But notice what they're practicing. They're not inventing the mathematics. They're learning to apply mathematics that already exists in complete form. The multiplication tables they copy are standard. The problem solutions they practice follow established procedures. They're being trained in a system, not discovering that system. This is education as transmission, not innovation. The scribes are preserving and perpetuating knowledge, not creating it. Which raises the question, where did the knowledge they're learning originate? In 2007, mathematicians Daniel Mansfield and Norman Wildberger published a paper arguing that Plimpton 32 represents the earliest known trigonometric table, a tool for working with triangles using exact ratios rather than the approximations required by the Greek trigonometric methods based on angles and circles. If their interpretation is correct, then Babylonian mathematics was not just sophisticated but fundamentally different from Greek mathematics. Perhaps more practical, perhaps more accurate, certainly organized according to different principles. The Greek mathematical tradition credits individual thinkers, Thales, Pythagoras, Euclid. We have records of mathematical schools, debates, refinements of ideas, competing approaches. Greek mathematics develops visibly over centuries with clear lines of transmission and evolution. Mesopotamian mathematics appears without this visible development. We have the tools, the tablets showing calculations, we have the products, the buildings that required engineering, the canals that required surveying, the administrative systems that required accounting. But we don't have the discovery narrative. The mathematics is just there, functioning from the earliest records. The Sumerians attributed their mathematical knowledge to the god Enki, the lord of wisdom who gave the Mi to humanity. The Mi included Nam-Shesh, the principles of measurement and mathematics. Later, Babylonian texts described the 7 Abkalalu, the antediluvian sages who brought the arts of civilization before the flood and whose wisdom was preserved in written form afterward. These are not origin stories in the modern sense. They are claims about transmission. Mathematics came from a source, was received by humanity, was preserved in texts, was transmitted through teaching. The Sumerians saw themselves as the recipients and preservers of mathematical knowledge, not its inventors. Modern mathematics education assumes that humans naturally discover mathematical relationships through practical experience. Counting sheep leads to arithmetic, dividing fields leads to geometry, observing patterns leads to abstract understanding. Given enough time, any culture will develop mathematics that reflects its needs. But Sumerian mathematics appears complete before we can observe the development process. The basic system is already standardized, the geometric relationships are already known, the measurement systems are already in place. Either the development happened so rapidly we cannot detect its stages in the archaeological record, or the Sumerians inherited mathematical knowledge that had been developed elsewhere or earlier. The tablets contain the mathematics but not its origin story. The calculations work, the systems function, the knowledge is preserved and transmitted through the scribal schools for 3,000 years. But the question remains: complete mathematics from where? Sophisticated systems developed when knowledge so useful it persists until today, given to humanity by whom Plimpton 322 sits in a climate-controlled case at Columbia University, its cuneiform numbers as precise today as when they were impressed into wet clay nearly 4,000 years ago. The tablet calculates. It doesn't explain. And in that silence lies another gap, the mathematics that appeared complete, the knowledge that functioned without visible foundation, the systems that worked from the beginning as though they remembered something that came before, stars mapped in the dark. The British Museum's collection includes tablets known as the Mool, Apin Compendium, named after the first two ununiform signs that begin the text Mool star, and Ain Plough, referring to the constellation we call the Triangulum. These tablets date to approximately 1000 BCE, CE, but compile astronomical knowledge that is demonstrably far older, preserved and copied by generations of Babylonian scribes who understood they were maintaining a tradition rather than inventing. Mool Apin contained star catalogues listing the constellations visible throughout the year, organized by their heliacal risings, the dates when they first become visible on the eastern horizon just before sunrise. The tablet tracks the movements of the sun, moon, and visible planets. It records the lengths of daylight and night at different times of year. It provides instructions for using stellar observations to determine dates and times. It includes mathematical rules for predicting planetary positions. This is not primitive stargazing. This is systematic astronomy organized into reference tables refined through years of observation, standardized for practical use in kendricks and divination. The knowledge demonstrated in MUL API requires sustained observation programs, multiple observers across multiple locations, tracking celestial phenomena over decades, and comparing results to identify reliable patterns. The tablet lists 66 stars and constellations divided into 3 paths: the path of Enlil, northern sky, the path of Anu, equatorial sky, and the path of Ea, southern sky. For each constellation, the text records when it rises, which other stars rise simultaneously, and how these risings relate to the seasons and agricultural activities. When the stars of Enlil have been finished, one big star, its light is dim, divides the sky in half and stands there. That is the star of Marduk, the Ford. This is describing Jupiter, identifying it not as a random wandering light, but as a specific planet whose behavior can be predicted and whose position has meaning. The Venus tablet of Amisaduqa, also in the British Museum collection, takes this further. It records the appearances and disappearances of Venus over a 21-year period during the reign of King Amisaduqa, approximately 1646 to 1626 BCE, tracking exactly when Venus was visible as morning star, when it vanished, when it reappeared as evening star, and when it disappeared again. The observations are recorded with lunar month dates and day numbers, creating a data set precise enough that modern astronomers can work backward from it to calculate exact dates, though debates about chronology continue because the Venus cycle repeats in patterns that create multiple possible solutions. What matters here is not the specific dates, but the nature of the observations. Someone had to watch the sky every morning and evening for 21 years, recording not just "I saw Venus," but Venus first appeared on month X, day Y, remained visible for Z days, then vanished on month A, day B. This requires institutional support, someone paying observers to watch rather than farm, a system for preserving records, a standardized calendar for dating observations, and most importantly, a reason to invest this effort. The reason for the Babylonians was divination. Celestial phenomena were omens, signs from the gods about earthly affairs. Changes in Venus's behavior could indicate changes in royal fortune, military success, agricultural yields, or political stability. But divination only works if you understand normal patterns well enough to recognize when something abnormal occurs. You cannot identify an omen unless you know what the sky usually does. This means the astronomical observations had to be continuous and long-term. You cannot suddenly decide to observe Venus and immediately know that its current behavior is unusual. You need a baseline decades of prior observations showing typical patterns. The 21-year Venus observations recorded on the Amisaduqa tablet are not the beginning of Babylonian astronomy. They are a representative sample from an ongoing observation program that must have been functioning for generations before this king's reign. How far back does that program extend? The tablet itself dates to approximately 1646 BCE, but the astronomical knowledge it demonstrates is clearly older. References to astronomical omens appear in texts from the Old Babylonian period 2600 BCE. These Sumerian texts that precede them already show awareness of planetary movements and lunar cycles. The kendrical systems used by Sumerian city-states in the 3rd millennium BCE required astronomical observations to maintain. Someone had to watch the moon, track its phases, and decide when to insert intercalary months to keep the lunar calendar aligned with the solar year. By the time we have written records of astronomical knowledge, that knowledge is already sophisticated. It already functions as a system. The stars are already organized into useful categories. The movements are already being tracked systematically. Either this all developed very rapidly in the centuries just before writing, or writing captured a tradition of observation that had been functioning without written records for a long time. Consider what precise astronomical observation requires. First, a stable viewing location with clear sightlines to the horizon. Second, consistent observation times. Someone has to be present at dawn and dusk every day to catch helical risings. Third, a method for recording what you see in a way that future observers can understand and compare. Fourth, institutional continuity. The knowledge must be maintained across generations with older observers training younger ones, preserving accumulated data, and ensuring the observation program continues even when specific individuals die or retire. The Sumerians possessed all of this. The ziggurats, massive temple platforms rising above the flat Mesopotamian plain, provided stable, elevated viewing platforms. The priestly classes had the institutional support and social position to dedicate time to observation rather than subsistence labor. The ununiform writing system provided a means to record observations in permanent form, and the culture clearly valued this knowledge enough to maintain it across centuries. But here is the puzzle. The earliest ziggurats, the earliest writing, and the earliest evidence of systematic astronomical knowledge all appear together in the Uruk period around 35,000–3000 BCE, not sequentially but simultaneously, as though the system was designed as a complete package. Build platforms for observation, develop notation for recording, establish priestly institutions for maintenance, begin systematic tracking. Or as though the system was being restored rather than created, as though someone knew that accurate astronomical knowledge required these specific elements and implemented them together because they had existed before as an integrated system. The Sumerians and Babylonians claimed their astronomical knowledge came from the Abkalu, the antediluvian sages who brought civilization before the flood. The god Enki, Lord of Wisdom, was credited with establishing the me that included observation of heaven. Later, Babylonian astronomical texts sometimes invoked the wisdom of ancient scholars or old experts, acknowledging that the knowledge they preserved was inherited, not originated by them. In the 1950s, scholars examining Babylonian astronomical tablets noticed something remarkable about certain eclipse predictions. They were too accurate for the mathematical models the tablets described. The predictions required observational data spanning several centuries to achieve that level of precision. This meant that by the time certain tablets were written, Babylonian astronomers had access to eclipse records extending back many generations, records that had been continuously maintained, carefully preserved, and systematically analyzed to refine predictive models. This is science in the modern sense. Systematic observation, data collection, pattern recognition, model building, prediction, verification, refinement. The Babylonians were doing astronomy, not just astrology. They understood they were tracking real physical phenomena whose behavior could be predicted if you accumulated enough data and analyzed it carefully. But this raises a question about continuity. How do you maintain an observation program across centuries without interruption? Civilizations collapse, cities are abandoned, wars disrupt institutions, floods destroy libraries. Yet somehow the astronomical knowledge persists, maintained through political upheavals, transmitted across dynastic changes, copied and recopied by scribes who preserve data they themselves might not fully understand because they knew it was valuable. The tablet Mullapin concludes with instructions for using stellar observations to determine the proper times for religious festivals, agricultural activities, and administrative decisions. The stars are not abstract. They are practical tools for organizing time and coordinating society, but practical tools only work if they're reliable, and reliability requires testing over long periods. How long did the Sumerians observe the sky before they were confident enough in their patterns to base their calendar on? How many generations watched Venus before they knew its cycle well enough to recognize omens in its deviations? How many years of eclipse records had to be compared before predictive models became accurate? The tablets show us the end result: organized star catalogues, precise planetary observations, functional predictive models. What they don't show is the development process, the learning curve, the failed attempts and corrected errors, the accumulation of data from scratch. Either that development happened in the centuries before writing during the Ubaid period when we have villages but no obvious evidence of organized astronomical observation programs, or the knowledge was inherited from a source that predates our current archaeological evidence. The Sumerians said their astronomical knowledge descended from heaven with the MI. They attributed it to the ante-Alluvian sages. They presented it as received wisdom, transmitted and preserved, not discovered and developed. Modern science struggles with this claim because our model of knowledge assumes gradual accumulation. Simple observations lead to pattern recognition, lead to predictive models, lead to refined understanding over many generations of work. The developmental stages should be visible in the record. But for Sumerian astronomy, as with Sumerian mathematics and writing, the stages are not clearly visible. The knowledge appears largely complete when we first encounter it. The system functions. The observations are systematic. The records are maintained. Stars mapped in the dark by observers who knew where to look and what to track and when to watch, as though they were following instructions rather than exploring. Knowledge deployed rather than discovered. Astronomy that works from the beginning, preserved through centuries, maintained across catastrophes, transmitted by scribes who called it ancient even when they recorded it. The tablets track the stars, but they don't explain who first knew which stars to track, or when that knowledge began, or where it came from before the scribes began writing it down. The sky remembers its patterns, the tablets remember the observations, and both suggest that what we call the beginning of astronomy might be the continuation of something older, something that crossed a gap we cannot yet explain. The temple that remembers itself. Approximately 8 miles southwest of the ancient city of in a region now dominated by desert, lie the ruins of Eridu. When archaeologists Satan Lloyd and Fuad Sapper excavated the site between 1946 and 1949, they uncovered a sequence of structures that reshaped how scholars understood the development of Mesopotamian religious architecture. What they found was not a gradual evolution from simple to complex, but rather a pattern of continuous rebuilding that maintained specific architectural principles across more than 3,000 years. The sequence begins with Temple 1, dating to approximately 5400 BCE, deep in the Ubaid period. The structure is small, a single room measuring about 3 to 545 meters, with walls made of sun-dried mud brick. In one wall is a niche facing the entrance. Before the niche sits a low mud brick platform interpreted as an altar. In the center of the room is a larger platform, likely for offerings. The entrance is oriented along a specific axis. Temple 2, built directly over Temple I after its abandonment, maintains exactly the same orientation and central axis. The room is slightly larger. The altar niche is in the same relative position. The offering platform grows but remains centrally positioned. The entrance faces the same direction. This pattern continues through 18 successive temple structures. Each is built directly atop its predecessor. Each maintains the same orientation. Each preserves the same basic layout, entrance, central offering area, alternate the entrance. Each generation expands the structure, adds architectural elaboration, buttresses, niches for additional offerings, decorated facades, but never deviates from the fundamental template established in Temple 1. By Temple X8, the final structure in the sequence dating to approximately 2000 BCE, the temple has become massive. The main room measures roughly 12 x 24 meters. The walls are elaborately decorated with engaged buttresses, creating a rhythmic pattern of projections and recesses. The altar platform is accessed by a stairway. Side rooms for storage and priestly activities surround the main chamber, but the orientation remains precisely the same as Temple 1. The central axis is identical. The altar faces the entrance across the same spatial relationship established 3,000 years earlier. This is not gradual religious development. This is maintenance of sacred architecture according to principles understood from the beginning. Temple Y is not a primitive attempt at temple building that later generations improved upon. Temple Y is already a complete expression of what a temple should be. It simply needs to grow larger as the community it serves grows larger. What knowledge allows Ubeda villages in 5400 BCE CE to establish architectural principles that will guide urban temple construction for 3 millennia? How do they know the exact orientation matters? How do they understand the relationship between entrance, altar, and offering space is sacred and must be preserved? The GDA cylinders, 2 large terracotta cylinders covered in Sumerian cuneiform and dating to approximately 225 BCE, provide a perspective on how the Sumerians themselves understood temple construction. Gouda was the NC ruler of Lagash, and these cylinders describe in extraordinary detail how he rebuilt the temple of Ningu, the patron god of his city. The cylinders, now in the Louvre Museum, contain over 1,400 lines of text and represent some of the finest examples of Sumerian literary composition. They describe Gouda receiving a dream vision in which the god Ningu shows him the plan for the temple. The text is explicit. GDA does not design the temple. He receives the design from divine revelation. The goddess Nanshe interprets his dream, explaining the measurements, materials, and construction procedures he must follow. Cylinder A describes the preparation. The house, from the moment its powers were allotted, from the moment its divine plans were perfected by holy Anash, it acted grandly, wondrously. When Enel had looked favourably upon the temple, Enu rising up in artful fashion, he gave it great powers. The temple's design comes from the sky god and is perfected before construction begins. Gaia's role is not to create, but to execute according to revealed specifications. The text then describes in meticulous detail the gathering of materials: cedar from Lebanon, gold from Melua, copper from the mountains, stone from quarries. These materials are not randomly chosen. Each has specific properties required for specific temple functions, as though the design specifies exact material requirements based on understanding of their characteristics. Cylinder B describes the actual construction and the completion ceremony. Throughout, the emphasis is on precision. He laid out the plan of the house with the holy ruler. He put in the brickwork for him with the holy measuring rod. The Anzu bird is stretching its talons against the wild bulls. Inside, it is like the interior of heaven. The temple is built to exact measurements using a divinely provided ruler. Its proportions reflect cosmic principle. Its interior recreates heavenly architecture on earth. This is not symbolic language about an architect designing a building and then attributing the design to gods for political legitimacy. The text specifies that Gaudia receives measurements, proportions, material requirements, and construction sequences through divine revelation because he does not possess this knowledge inherently. The knowledge exists elsewhere in heaven with the gods and must be transmitted to him before he can build. The same pattern appears in other Sumerian temple construction texts. The ruler receives the plan from the gods. The dimensions are specified exactly. The orientation is fixed according to celestial alignments. The proportions reflect divine mathematics. The construction follows procedures that must be executed precisely to create sacred space. What the texts describe is a system of knowledge about temple architecture that precedes any individual building project. The knowledge exists as a complete body of principles: how to orient a temple, how to proportion its spaces, how to select materials, how to perform consecration ritual. Gudea does not invent this system. He receives it, applies it, and thereby creates a structure that connects earth to heaven. Archaeological evidence supports the textual claims about architectural precision. Sumerian temples from different cities and different periods show remarkable consistency in proportional relationships, orientation patterns, and spatial organization. Someone established standards that multiple cities maintained across centuries. The temples are not experiments, they are applications of an established architectural science. Consider what this requires: astronomical knowledge to establish proper orientation, mathematical knowledge to calculate proportions, geometric knowledge to lay out plans, engineering knowledge to construct stable structures from mud brick, material science to select appropriate stones, woods, and metals, and ritual knowledge to properly consecrate the completed space. Each of these knowledge domains is sophisticated on its own. Together they form an integrated system of temple construction that appears already complete in the earliest examples we can excavate. The ziggurats, massive stepped platforms topped with temples, represent this integration most dramatically. The most famous is the ziggurat of Ur, built by King Uramu around 2000 BCE and extensively restored by Nabonidus in the 6th century BCE. But ziggurats appear across Mesopotamian cities from the 3rd millennium onward, each following similar design principles: multiple levels accessed by staircases, massive mud brick cores, orientation toward cardinal directions, temple shrine at the summit. Building a ziggurat requires solving complex engineering problems. The mud brick core must be stable enough to support its own weight without collapsing or sliding. Drainage systems must prevent water infiltration that would undermine the structure. The staircases must be properly proportioned for safe ascent. The summit platform must be level and structurally sound. Ancient ziggurats show evidence of sophisticated engineering solutions: drainage holes, bitumen waterproofing, woven rematting layers to provide tensile strength, calculated weight distribution. These solutions do not appear in the archaeological record as trial and error development. The earliest ziggurats are already competently engineered. Later ziggurats are larger and more elaborate, but they don't show the kind of structural failures and redesigns you'd expect if engineers were learning how to build these structures for the first time. The Sumerians attributed their architectural knowledge to the god Enki and to the antediluvian sages who brought the arts of civilization before the flood. Later texts refer to ancient plans and old foundations that guide new construction. When Leonidas rebuilt temples in the 6th century BCE, he excavated through earlier levels to find the original foundation stones, claiming he was restoring temples to their proper ancient forms rather than creating new designs. This is memory architecture. Each generation builds not according to innovation, but according to tradition. The tradition is ancient. The plans are revealed. The knowledge is preserved. The temples remember themselves through the continuity of their spatial relationships, their proportions, their orientations maintained across millennia by builders who understood they were maintaining rather than inventing. The 18 temples at Erasure are not 18 attempts to build a proper temple with each generation learning from the mistakes of the previous one. They are 18 expressions of the same temple knowledge, scaled up as the community grows, elaborated as resources allow, but fundamentally unchanged in their sacred geometry. From 5400 BCE to 2000 BCE, who taught the builders of Temple 1 how to create sacred space? Where did they learn that orientation matters, that the altar must face the entrance, that the offering platform must be centrally positioned? How did they know that these principles would remain valid for 3,000 years? The tablets say the gods taught them. The texts say the plans were revealed. The archaeology shows that the knowledge was preserved with extraordinary precision across epochs that saw kingdoms rise and fall, languages change, political systems transform, yet the temples maintained their sacred architecture without deviation. This is knowledge that remembers itself, systems that preserve their own principles across catastrophes and cultural changes. Architecture that teaches each generation how to build according to templates established before cities existed. The template Eridu rises layer by layer, century by century, maintaining alignment with a template fixed at the beginning. The gaps we cannot explain are not what the Sumerians failed to develop, but what they knew from the start. Where that knowledge came from and how they maintained it with such precision across so much time. The ruins stand in the desert, 18 layers of sacred memory, each teaching the next how to remember what was revealed before the first stone was laid, before the first brick was formed, before the first temple rose above the plain as a marker between earth and the heaven from which kingship descended. Wisdom before the waters rose. The tablets classified as the instructions of Shuruppak exist in multiple copies found at several Mesopotamian sites, but most significantly at Abu Salabik, excavated in the 1960s and 1970s. These tablets date to approximately 2600 BCE, making them among the oldest extensive literary texts in human history, but the content they preserve claims to be far older. Wisdom from before the flood transmitted from father to son at the boundary between the antediluvian world and the catastrophe that destroyed it. The text presents itself as the advice of Shuruppak, ruler of the city of Shulak, the last antediluvian city listed in the Sumerian King List before the flood given to his son Zusudra. The same Zusudra who in the Eridu Genesis survives the flood by building a boat on Enki's instructions. This is not coincidental framing. The text explicitly positions itself as pre-flood wisdom preserved across the catastrophe by the flood survivor, transmitted down through generations and eventually recorded in written form by Sumerian scribes. The instructions themselves are practical, concerned with daily life, social relationships, property management, and ethical conduct. Do not buy a donkey which brays too much, it will split your midriff. This is agricultural advice. A brain donkey is difficult to work with and will make your labor miserable. Do not vouch for someone. That man will hold it against you. This is social wisdom. Becoming someone's guarantor in a loan creates obligations that strain friendships. Do not pass judgment when you drink beer. This is legal counsel. Intoxication impairs decision-making in matters requiring clarity. Hundreds of proverbs arranged thematically covering topics from marriage and family to trade and business to justice and leadership. The wisdom is not mystical or religious. It is the accumulated practical knowledge of a functioning society, how to manage assets, how to maintain reputation, how to navigate social hierarchies, how to raise children, how to conduct legal affairs. This is the knowledge a civilization needs to function smoothly. Not the knowledge required to create civilization initially, not how to invent agriculture or develop writing or build cities, but the social wisdom required to make civilization livable once it exists. The instructions assume the existence of property ownership, legal systems, social stratification, commercial relationships, and administrative authority. They guide behavior within that framework. Here is what matters. This comprehensive social wisdom is attributed to the antediluvian world. It is presented as the knowledge Shuruppak possessed before the flood and passed to his son, who would survive the catastrophe. The Sumerian scribes who copied these tablets understood they were preserving wisdom that predated their own civilization, knowledge that had crossed the boundary event of the flood through deliberate transmission. The frame narrative is crucial. Shuruppak speaks to Zusudra. In those days, in those far remote days, in those nights, in those far remote nights, in those years, in those far remote years, Shuruppak gave instructions to his son. Shuruppak, the son of Ubara, Tutu, gave instructions to his sons Zusudra. The repetition of far remote emphasizes temporal distance. This is not recent wisdom. This is ancient knowledge from an ancient time. The text signals to its audience that what follows comes from before, from the world that existed prior to the catastrophe that divided history. Multiple copies of the instructions survive, found at different sites dating to different periods. The earliest come from Abu Salabik around 2600 BCE. Later copies from Nippur date to the Old Babylonian period around 1800 BCE. Still later, copies exist from the first millennium BCE. Across nearly 2,000 years, scribes copied this text, preserving its claim to be antediluvian wisdom. They did not update it or revise it significantly. They copied it as preservation, maintaining knowledge from before. This pattern of preservation appears across Sumerian and Babylonian literary culture. Many texts identify themselves as ancient, copied from older sources, preserved from earlier times. Coffons at the ends of tablets sometimes state that the scribe copied from an old, damaged text, carefully preserving what could be read even when parts were illegible. This is not literature being created. This is literature being conserved. The scribal schools, the Edu Barber, trained students primarily in copying. A student scribe would copy standard texts, literary compositions, hymns, proverbs, mathematical tables, astronomical observations, not to learn composition, but to learn the tradition. The curriculum was conservative, focused on maintaining knowledge rather than generating new knowledge. Innovation was not the goal. Accurate transmission was the goal. This makes sense if the culture understands that its knowledge is inherited rather than invented. If you believe your wisdom comes from ancient sources, from the gods, from antediluvian sages, then your responsibility is preservation, not innovation. You copy the texts carefully. You maintain the language even when it becomes archaic. You preserve what you received because losing it would mean losing irreplaceable knowledge. The instructions of Shurupak claim to be practical wisdom from before the flood, preserved by the flood survivor, transmitted through generations, recorded by scribes who labeled it ancient even when they first wrote it down. If we take this claim seriously, not as literal history necessarily, but as cultural self-standing, then the Sumerians saw themselves as preservers of pre-catastrophe knowledge, not as the originators of civilization, but as its restorers and maintainers. This perspective explains patterns that otherwise seem puzzling. Why does writing appear so suddenly and completely? Because it's being restored or re-implemented after a gap, not invented from scratch. Why are mathematical and astronomical systems so sophisticated so early? Because they're being preserved from earlier sources, not developed for the first time. Why do temple architectures remain consistent for millennia? Because they're maintaining revealed plans, not experimenting with new designs. The wisdom in the instructions is not primitive. It assumes complex social structures, sophisticated legal frameworks, and nuanced understanding of human behavior. This is not the wisdom of people just learning to farm and live in villages. This is the accumulated knowledge of a developed civilization, knowledge about how to function in urban environments, how to manage property, how to conduct business, how to navigate social hierarchies. If Shurupak's wisdom comes from before the flood, and the flood is the boundary event that divides antediluvian civilization from post-flood restoration, then the instructions are evidence that sophisticated social knowledge existed before that boundary, that the antediluvian world was not primitive but civilized, and that its knowledge was sufficiently valued to be deliberately preserved across catastrophe. The text itself describes this preservation. Shurupak speaks to Zusudra, knowing implicitly that Zusudra will survive what is coming. The instructions are not just general advice. They are knowledge transmission to someone who will carry that knowledge forward. The wisdom must cross the gap. Zusudra is the bridge. Other Mesopotamian texts describe the Akkalu, the 7 sages who brought civilization before the flood, and whose wisdom was preserved in written form afterward. These sages are associated with the god Enki, the lord of wisdom and fresh water, who warned humanity about the coming deluge. The tradition is consistent. Knowledge existed before the flood was preserved deliberately, was transmitted to post-flood civilization, was maintained through scribal copying. Modern scholarship treats the Apkallu as mythological, the instructions as wisdom literature using fictional framing, the claims about antediluvian sources as literary conventions. But notice what this requires us to believe. The Sumerians created sophisticated social wisdom, then invented a backstory claiming it came from before a flood, then maintained that backstory for 2,000 years, even though they knew it was fiction. Alternatively, the Sumerians inherited wisdom they genuinely believed was ancient, associated it with the pre-flood period because their traditions told them it originated then, and preserved it carefully because they understood it as irreplaceable knowledge from a time before their own. The tablets don't explain which interpretation is correct. They simply preserve the wisdom and maintain the claim. This is from before, from Shuruppak to Zusudra, from before the waters rose to after they receded, from the antediluvian world to the civilization that restored itself afterward. What the instructions reveal is not primarily the content of Sumerian wisdom, though that is significant, but the Sumerian understanding of where that wisdom came from, not from their own invention, not from their own development, but from before, from earlier, from sources they labeled ancient, even at the beginning of their written tradition. Wisdom before the waters rose, knowledge preserved across catastrophe, social understanding transmitted through the gap, and scribes who understood their task was not creation but conservation. Copying the instructions carefully, maintaining the text across centuries, preserving what Shuruppak taught Zusudra before the flood swept over and then descended again. The tablets hold the wisdom, the tradition holds the frame, and both point toward knowledge that predates the civilization that preserved it, suggesting once more that what we call beginning might be continuation, restoration, preservation of something that came before the gap we cannot yet explain. The healers who knew too much. In the 19th century, excavations at Nineveh, the ancient Assyrian capital, uncovered the palace library of King Ashurnapal, who ruled from 668 to 627 BCE. Among the tens of thousands of ununiform tablets in this library were extensive medical texts, including portions of what scholars now call the Diagnostic Handbook, a comprehensive medical encyclopedia that catalogues diseases, symptoms, prognosis, and treatments with a level of systematic organization that surprises researchers who expected ancient medicine to be primarily magical or superstitious. The Diagnostic Handbook, primarily dating to manuscripts from the first millennium BCE, but clearly based on much older material, organizes medical knowledge according to a specific methodology. The text proceeds systematically from head to foot, describing symptoms observed in each body region, providing differential diagnosis, predicting outcomes, and in some versions prescribing treatments. If a man's temples are diseased, his eyes are yellow, and his forehead is cold, hand of the god Shamash, he will recover. If a man's skull pounds him repeatedly and his eyes are yellow, he will die. This is clinical observation recorded systematically. Not all predictions were accurate. Ancient physicians didn't understand infectious disease mechanisms or many physiological processes. But the method is fundamentally scientific. Observe symptoms, recognize patterns, predict outcomes based on prior cases, adjust treatments based on what works. Earlier Sumerian and Old Babylonian medical tablets demonstrate that this tradition extends back at least to 2000 BCE and likely earlier. A tablet from Nippur dating to approximately 2000 BCE and now in the University of Pennsylvania Museum contains medical prescriptions using botanical, mineral, and animal ingredients compounded in specific ratios prepared through specific procedures, grinding, boiling, filtering, and applied in specific ways depending on the condition being treated. The prescriptions are not magical incantations, they are pharmaceutical recipes, pulverized turpentine resin, grind it together with hot bitumen, spread it on felt, and apply to affected area. This is topical treatment for skin conditions using ingredients with antiseptic properties, applied in a manner that would provide some genuine therapeutic effect. Other tablets describe surgical procedures. A text fragment describes draining an abscess from the scalp, make an incision, allow the pus to drain, clean the wound, apply medication, bandage. This is recognizable surgical procedure. incision, drainage, wound care, follow-up treatment. The text doesn't claim the procedure will be accomplished through prayer or divine intervention. It describes a physical intervention with expected physical results. Fracture treatment appears in several tablets. Align the broken bone, splint the limb, immobilize the affected area, check regularly for proper healing. This is orthopedic medicine based on understanding that bones can heal if properly positioned and stabilized. The sophistication of Mesopotamian medicine is not primarily in their theoretical understanding. They had wrong ideas about anatomy and disease causation, but in their empirical approach they observed what worked, recorded successful treatments, taught those treatments to students, and maintained medical knowledge across generations through the same scribal schools that preserved literature, mathematics, and astronomy. Medical education in ancient Mesopotamia involved apprenticeship with established physicians, study of canonical medical texts, and practice under supervision. A physician needed to know pharmacology, which plants had which effects, which minerals were useful for which conditions. They needed diagnostic skill, recognizing diseases from symptoms, distinguishing between similar conditions. They needed procedural knowledge, how to perform surgery, set bones, compound medicines. They needed professional ethics. Texts describe physicians being held accountable for outcomes with different standards for treating free persons versus slaves. This is not primitive healing. This is organized medicine practiced by trained specialists guided by accumulated knowledge, subject to professional standards. It assumes an educational infrastructure, a textual tradition and institutional continuity across generations. Where did this knowledge come from? Medical knowledge typically accumulates slowly through trial and error. Someone tries a plant extract on a wound. It helps. They remember and try it again. Over many cases, patterns emerge. This plant helps with infections. That plant reduces inflammation. This mineral promotes healing. Eventually, through extensive experience, practitioners develop a pharmacopoeia, a catalogue of useful substances and their applications. But Mesopotamian medical texts don't show this accumulation process. The earliest medical tablets already contain sophisticated pharmacopoeias with dozens of substances used in specific combinations for specific purposes. The diagnostic texts already employ systematic organizational principles. The surgical procedures already reflect understanding of proper technique. Either medical knowledge developed very rapidly in the centuries before writing through intensive experimentation that left no archaeological trace, or the Sumerians inherited medical knowledge that had been developed earlier or elsewhere. The Sumerians themselves attributed medical knowledge to the god Enki and to the goddess Gula, the great physician who restores the dead to life. Later texts credit the antediluvian sages with teaching medicine to humanity before the flood. As with mathematics, astronomy, and architecture, the Mesopotamian tradition frames medical knowledge as received rather than invented, as wisdom given by gods and preserved by humans. A fascinating detail. Many Mesopotamian medical texts include what scholars call incantations alongside physical treatments. A typical prescription might specify botanical ingredients, preparation method, application, procedure, and then conclude with a formula to be recited during treatment. Modern analysis often separates the real medicine, the physical treatment, from the magic, the verbal formula, assuming the physical part is based on empirical knowledge while the incantation is superstition. But notice what the texts themselves suggest. The treatment is holistic, combining physical intervention with psychological, spiritual support. The incantation might calm the patient, establish trust between physician and sufferer, invoke divine assistance, and create a ritual context that enhances healing. Modern medicine recognizes the placebo effect, the power of belief and recovery, and the importance of the physician-patient relationship. The Mesopotamian physicians were addressing these factors through their incantations, not instead of providing physical treatment, but alongside it. This suggests sophisticated understanding of healing that goes beyond mere pharmacology or surgical technique. The physicians understood that recovery involves both body and mind, that treatment works better when the patient believes it will work, that invoking divine assistance provides psychological comfort even if the gods don't physically intervene. This is nuanced medical practice, not primitive superstition. The Diagnostic Handbook's systematic organization, proceeding head to foot, cataloging symptoms by body region, demonstrates abstract organizational thinking applied to medical knowledge. Someone recognized that the body of medical knowledge had grown large enough to require systematic organization for efficient reference. This is not medical practice itself, but meta-knowledge. Knowledge about how to organize knowledge, how to make it teachable, how to ensure it can be transmitted to the next generation of physicians. Educational texts for training physicians show students copying standard diagnostic series, learning to recognize symptoms, memorizing pharmacapers, practicing medical calculations. The curriculum is conservat. Learn what previous generations learned. Preserve the medical tradition. Maintain the knowledge. Experimentation and innovation likely happened, but the emphasis was on preserving proven methods rather than seeking novelty. Why would a culture emphasize preservation over innovation in medicine? If you believe your medical knowledge was given by gods or inherited from antediluvian sages, then your responsibility is to maintain that knowledge, not to improve it. The ancient sources are assumed to be authoritative, complete, and effective. Your task is to learn the tradition faithfully and apply it accurately. This attitude makes sense if medical knowledge appeared relatively complete at the beginning of your written tradition. If the earliest medical texts your culture possesses already contain sophisticated treatments and systematic organization, then you naturally assume this knowledge comes from somewhere older, from sources that precede your written records. Archaeological evidence provides some support for this view. Skeletal remains from ancient Mesopotamia show evidence of successful surgeries, trepanation, skull surgery with signs of healing afterward, meaning the patient survived the procedure, bone fractures that healed properly, suggesting competent orthopedic treatment, dental work, including draining abscesses and possibly filing teeth. These are not failed experiments, they are successful medical interventions. The success rate implies competent practitioners using effective techniques, but competence and effectiveness require training and knowledge. Where did the first generation of Mesopotamian physicians get their training? Who taught them which plants were medicinal, which procedures were safe, which treatments worked? The standard historical answer is that medical knowledge accumulated gradually through trial and error across generations before writing emerged to record it. This is certainly possible, but it requires us to explain why the earliest written medical texts are already sophisticated and systematically organized rather than showing the expected progression from simple to complex. The Mesopotamian answer preserved in their texts is that medical knowledge was taught to humanity by divine figures and antediluvian sages, preserved through catastrophe, transmitted to subsequent generations through teaching and texts. The physicians understood themselves as inheritors and preservers of ancient medical wisdom, not as the originators of medical science. Modern scholarship can dismiss the attribution to gods and sages as mythological framing, but dismissing the attribution doesn't answer the underlying question. Where did the medical knowledge that appears in the earliest Sumerian tablets actually come from? How did it achieve sophistication and organization so early? Why do we lack evidence of the developmental stages that should precede competent medical practice? The tablets heal when their instructions are followed. The treatments work often enough to be worth recording and teaching. The diagnostic methods recognize patterns and make predictions. The physicians function as professionals with specialized knowledge and standardized training. The system works, but its origins remain obscure, hidden behind the gap between when medical knowledge must have developed and when our written records begin. The healers knew how to drain abscesses, set bones, compound medicines, recognize symptoms, predict outcomes, and train students. They knew this at the beginning of written records. The tablets say they were taught by gods and sages from before the flood. Modern science says they must have learned through experience in earlier unrecorded times. Both explanations acknowledge that the knowledge existed before we can document it, that it crossed a gap between whenever it was learned and when it was written down. The Sumerians filled that gap with divine instruction and antediluvian wisdom. We fill it with hypothetical development periods for which we lack direct evidence. The healers knew, the tablets preserve what they knew, and what they preserved suggests knowledge that appeared complete early enough to trouble our developmental models, sophisticated enough to seem inherited rather than invented, effective enough to be maintained for millennia by physicians who understood their role, was preservation of ancient wisdom rather than innovation in medical science. The schools that taught the ancient. In 1889, the University of Pennsylvania began excavations at Nippur, a city the Sumerians considered sacred, home to the temple of Enlil, chief of the gods. Over decades of excavation, archaeologists uncovered thousands of clay tablets, administrative records, literary texts, mathematical exercises, lexical lists, hymns, and letters. Among these discoveries was evidence of an entire quarter of the city devoted to education, the Ajaba, the tablet house, where young scribes learned the knowledge their civilization considered essential. The tablets from Nippur's scribal schools date primarily to the Old Babylonian period around 2600 BCE, but they preserve and teach material that is demonstrably older, often written in Sumerian, a language that by this period was no longer spoken in daily life, but maintained as the language of scholarship, religion, and high culture, much like Latin in medieval Europe. The curriculum was extensive and standardized. Excavations at Nippur and other cities reveal similar sequences of training tablets, suggesting that scribal education followed a common program across Mesopotamia. This wasn't local tradition varying from city to city. This was a standardized educational system maintained across political boundaries. The training began with sign lists. Students copied the basic ununiform signs repeatedly, learning their shapes and the sounds or concepts they represented. Then came lexical lists, organized vocabularies, grouping words by category. There were lists of trees, lists of stones, lists of animals, lists of tools, lists of professions, lists of gods. These lists weren't just vocabulary lessons, they were systematic organizations of knowledge, taxonomies of the natural and social world. A student scribe would copy the list of trees, learning not just the uniform signs, but the actual varieties of trees, their names, their uses, their characteristics. The list of stones taught minology, types of stones, their colors, their hardness, where they were found, what they were used for. The list of professions taught social structure, what roles existed in society, what each profession did, how they ranked relative to each other. This is encyclopedia education. The scribal schools weren't just teaching literacy, they were transmitting the complete knowledge system of Mesopotamian civilization. A fully trained scribe needed to know mathematics, astronomy, law, literature, history, geography, agriculture, architecture, medicine, music, and ritual. The EdBA produced not just clerks who could write receipts, but educated professionals who could serve in temple administration, royal bureaucracy, legal affairs, or teaching. The mathematical curriculum included multiplication tables, reciprocal tables, tables of squares and cubes, and problem sets covering practical geometry, algebra, and calculation. Students copied standard mathematical texts, then worked through progressively more complex problems, calculating field areas, dividing inheritances, determining building materials needed for construction projects, computing compound interest, solving for unknown quantities. The tablets show the work, a student's calculations scratched in the clay, sometimes with errors, sometimes corrected by a teacher's hand. This is education. We recognize students struggling with difficult concepts, teachers providing feedback, knowledge transmitted through practice and repetition. But notice what's being taught. The students aren't learning to develop mathematics, they're learning to use mathematics that already exists in complete form. The multiplication tables they copy are standard, the geometric formulas they apply are established. The problem-solving methods they practice are traditional. They are being trained in a system, not invited to create new systems. The literary curriculum included copying classic Sumerian texts, myths about the gods, hymns to temples, royal inscriptions, wisdom literature. By the Old Babylonian period, these texts were already ancient. Many had been composed in the Earth Third period 200 to 2000 BCE or earlier. Students were copying texts that were 500, 800, sometimes over 1,000 years old, preserving them through their educational exercises. This is how the Sumerian literary tradition survived even after Sumerian ceased to be a spoken language. Each generation of scribes copied the old texts as part of their training, maintaining the tradition through continuous replication. The texts were valued not because they were new or innovative, but because they were old and authoritative. The instructions of Shura Tupac was a standard text in the scribal curriculum. Students copied it, learned it, preserved it not as fiction or mythology, but as wisdom worth maintaining. The same with the Sumerian King List, with astronomical tables, with mathematical problem sets, with hymns and myths. The curriculum was fundamentally conservative. Learn what the ancients knew, preserve it accurately, pass it forward. The Edda produced the continuity that maintained Mesopotamian civilization for 3 millennia. Despite political upheavals, cities rising and falling, dynasties replacing each other, empires conquering and collapsing, the knowledge system persisted because the scribal schools continued training students in the same curriculum, copying the same texts, maintaining the same standards. A text from Nippur known as School Days provides a window into daily life in the Edda. It's a literary composition, probably idealized, but it describes a student's routine. Waking early, bringing lunch prepared by his mother, arriving at school, reciting his lessons, copying his assignment, being beaten by the teacher for mistakes or misbehavior, going home, showing his father what he copied, doing it again the next day. The text is humorous. The student complains about the strictness. The father eventually bribes the teacher with gifts to gain favor for his son, but it reveals the seriousness with which education was conducted. Teachers had authority to discipline students physically. Standards were high. Accuracy in copying was demanded. Education was not casual. It was rigorous, disciplined, and essential for social advancement. Becoming a scribe was a path to prestigious positions. Scribes served in temples, managing offerings and maintaining archives. They served in palaces, recording royal decrees and composing official correspondence. They served in courts, writing legal documents and witnessing contracts. They served in trade, keeping accounts and verifying transactions. They taught the next generation. The Ajaba was the gateway to participation in the literate elite that actually ran Mesopotamian civilization. But that elite understood its function as preservation. A text known as the supervisor's advice to a younger scribe makes this explicit. A scribe who does not know Sumerian, what kind of scribe is he? This is from a period when Sumerian was already a dead language maintained only by scribes. Yet knowing Sumerian remained essential to scribal identity because Sumerian was the language of the ancient texts, the old knowledge, the wisdom that must be preserved. The scribes weren't just copying texts, they could read in translation. They were maintaining the original language because they understood that knowledge is embedded in language, that translations lose nuance, that preserving the ancient texts in their original form was crucial to preserving the knowledge itself. This is scholarly consciousness at a sophisticated level. The inscription credits the wisdom of Ea and the sage Adapa for the architectural knowledge used in the construction. Adapur appears in Mesopotamian literature as a primordial human created by Enki who possessed divine wisdom and served as a model for later sages. The king attributes his architectural knowledge not to contemporary experts, but to ancient sources of wisdom. The pattern is consistent. When Mesopotamian texts describe where knowledge comes from, they point backward to divine or semi-divine teachers from before or just after the flood. They do not claim that humans invented writing or mathematics or astronomy through their own experimentation. They claim these were taught to humanity by beings who possessed this knowledge already and transmitted it deliberately. The god Enki appears repeatedly as the source or sponsor of this transmitted knowledge, Enki is the god of fresh water, wisdom, crafts, and magic. His temple at Eridu is built over the Abzu, the freshwater abyss that represents primordial wisdom. Myths describe Enki possessing the me, the fundamental principles of civilization, and distributing them to various cities and institutions, sometimes through direct action, sometimes through intermediaries like the Apkallu. The Sumerian composition Inanna and Enki describes the goddess Inanna traveling to Eridu, getting Enki intoxicated and tricking him into giving her the mi, which she then transports to her city Uruk. The text lists over 100 emtalos: kingship, priestly office, truth, music, sexual intercourse, prostitution, law, architecture, metalwork, writing, and many more. These are presented as discrete principles that can be possessed, transferred, and implemented. They are not abstract concepts, they are functional knowledge systems that enable civilization. The framing is clear. Civilization's knowledge exists before humans fully possess it. The mi exist with the gods. Humans acquire them through divine gift or clever appropriation. Once acquired, the knowledge enables specific civilizational functions. The transmission is the crucial event, not invention, not discovery, but reception. This is markedly different from how modern Western culture frames knowledge acquisition. We celebrate inventors and discoverers. The Wright brothers inventing flight, Edison inventing the light bulb, Newton discovering gravity, Darwin discovering evolution. We construct origin stories around individual genius and experimental breakthrough. Knowledge is created by humans through observation and ingenuity. The Mesopotamian framing inverts this. Knowledge exists prior to human use. Humans receive it from sources external to themselves. Gods, sages, divine revelation, ancient teaching. Human civilization implements knowledge it did not originate. The proper human role is not invention, but learning, not discovery, but preservation, not innovation, but faithful application of received wisdom. This framing appears so consistently across 3,000 years of Mesopotamian texts that it seems to represent genuine cultural self-standing, not just literary convention. The Sumerians really believed their knowledge was given to them. The Babylonians really believed they were inheriting wisdom from ancient sources. The scribes really understood themselves as preserving teachings that originated elsewhere. Modern scholarship can explain this as a cultural tendency to project authority onto the past to legitimate present practices by claiming ancient origins to attribute human achievements to gods for theological or political purposes. Every ancient culture does this to some degree. Attribute human accomplishments to divine favor. Credit kings with victories the gods granted. Frame cultural practices as divinely ordained. But the Mesopotamian pattern is more specific than generic claims about divine favor. The texts identify particular sages who taught particular knowledge systems at particular times. They maintain consistent traditions about these figures across centuries. They frame knowledge transmission as deliberate teaching, not vague inspiration. The Apkallu are not gods blessing humanity from afar. They are teachers physically present, instructing students, transmitting specific information. What if we take the text at face value, not as literal history, but as preserved tradition? What if Sumerian culture maintained memory of knowledge transmission from older sources remembered in their tradition as antediluvian sages or divine teachers and preserved this memory through their mythological and religious texts? In this reading, the Apkallu might represent actual transmission events, knowledge received from earlier cultures, from survivors of catastrophes, from sources that predated Sumerian civilization as we know it archaeologically. The fish symbolism might represent foreign origin coming across the sea or cultural difference. Amphibious beings as metaphor for those who belong to both old and new worlds, bridging the transition. The attribution to Enki might locate this knowledge in the religious complex at Eridu, the oldest city, where traditions were maintained across the Ubide to Uruk transition. The texts cannot prove this reading. They preserve tradition, not documentation. But they consistently present knowledge as transmitted rather than invented, received from identifiable sources rather than discovered through experiment, maintained through preservation rather than generated through innovation. When Gudea receives temple plans in a dream, he is experiencing knowledge transmission. The design exists before he knows it. He receives it, understands it, and implements it. When scribal students copy ancient texts, they are participating in knowledge transmission. The texts exist before they learn them. They receive them, master them, and pass them forward. When astronomers consult old observation records, they are using transmitted knowledge. The data existed before they analyzed it. They receive it, apply it, and extend it. Transmission is the fundamental model of knowledge in Mesopotamian culture, and the texts attribute the original transmission to specific figures from specific times, predominantly from before the catastrophe that divided history from the Akalu and from Enki and from the antediluvian cities where kingship first functioned and knowledge first existed. Modern science requires evidence beyond textual tradition, archaeological verification, independent corroboration, mechanisms that explain knowledge, origin without invoking divine teaching or semi-mythical sages. The Mesopotamian model doesn't meet these standards because it relies on claims we cannot verify about beings we cannot confirm existed, but the texts remain. For 3,000 years, Mesopotamian civilization maintained that it was taught, that knowledge descended, that the sages transmitted, that Enki gave the me, that the Abkaru brought civilization, that kingship came from heaven, that what humans possessed was received, not invented. The consistency of this claim across millennia, across dynasties, across languages, Sumerian and Akkadian, across political systems, city-states, regional kingdoms, empires, suggests it represents something fundamental to Mesopotamian cultural self-understanding. They believe they were preservers and appliers of knowledge that originated elsewhere, with others who taught them. The text says, they taught us. The tablets preserve the claim, and the claim points to transmission across a gap from sources before the flood, from teachers whose names the texts preserve and whose wisdom the texts insist made civilization possible. Whether those teachers were literal beings, symbolic representations of knowledge transmission, or cultural memory of actual teaching lineages, the result is the same. Mesopotamian civilization understood its knowledge as inherited, not created, as received wisdom maintained across time, preserved through teaching, transmitted to each generation by the previous one, stretching back ultimately to sources they called divine, and sages they called divine, and sages they called antediluvian. The problem science doesn't solve. When we gather the patterns documented in previous chapters, a coherent picture emerges, one that creates a problem for our standard models of civilizational development. Knowledge systems appear complete at the beginning of written records without visible developmental stages. Writing emerges already capable of recording complex ideas. Mathematics functions with sophisticated base 60 organization. Astronomy demonstrates systematic observation programs. Medicine shows comprehensive pharmacopoeias and surgical procedures. Architecture operates according to established proportional systems and cosmic alignments. Measurement standards are already unified across regions. Legal concepts are already abstract enough for complex contracts. These systems don't show the expected progression from simple to complex, from experimental to refined, from local variation to standardization. They appear largely formed when we first encounter them in the archaeological record. The chronological framework presents a problem. The Sumerian King List places 2,400 years of antediluvian kingship before a flood that serves as the pivot point of history. After the flood, civilization resumes with the same knowledge, systems essentially intact. The text presents this as straightforward chronology maintained across centuries of copying preserved by scribes who accepted it as their historical framework. Modern chronology cannot accommodate 200 years of pre-flood civilization. Our models of human development place the emergence of agriculture around 10,000 BCE, the first cities around 4,000 BCE and writing around 3,200 BCE. There is no room in this timeline for a prior civilization spanning hundreds of thousands of years. Yet the Sumerians insisted on this chronology. They did not present it as symbolic or metaphorical. They treated it as history as the foundation for understanding their own legitimacy and continuity. They knew how to use practical numbers. Their administrative tablets show realistic accounting, but they maintained impossible numbers in their king list, suggesting they faced a chronological problem they couldn't resolve except by recording what their sources told them. The cultural self-standing is consistent. Sumerian texts attribute their knowledge to divine teaching, to antediluvian sages, to transmission from sources that preceded them. They do not claim to have invented writing or discovered mathematics or developed astronomy through their own efforts. They claim to have received these systems, learned them from teachers, preserved them from ancient sources. This is not generic attribution of human achievements to gods. This is specific, consistent, repeated claims that identifiable beings taught identifiable knowledge systems at identifiable times, primarily before the flood that divided history. The preservation mechanisms are sophisticated. The scribal schools maintain texts for millennia. The astronomical observation programs continued across political upheavals. The mathematical systems remain consistent across cities and centuries. The architectural principles were preserved through continuous rebuilding. The temple at Eridu maintained its sacred geometry for 3,000 years. This degree of preservation suggests institutional commitment to maintaining knowledge rather than generating new knowledge. The culture valued continuity, accuracy, transmission, and conservation. Innovation was not the primary goal, preservation was the primary goal. The transitional gap troubles us. The Ubaid period shows nearly 2,000 years of gradual village development. Then the Uruk period shows rapid emergence of complete systems within a few centuries. The transition is too fast and too comprehensive for comfortable explanation through organic development. Migration might explain some transfer of knowledge, but the archaeological evidence shows cultural continuity, not population replacement. Environmental factors might explain social complexity, but they don't explain where complete knowledge systems came from. Rapid development in perishable materials might explain the lack of earlier evidence, but it requires us to imagine extensive UB knowledge systems for which we have no indication. The Sumerian explanation that civilization was restored after catastrophe using preserved knowledge fits the pattern but requires accepting claims about antediluvian civilization and knowledge transmission that our models don't permit. So we face a problem. How do we explain knowledge systems that appear complete, are attributed by their users to transmitted teaching, are preserved with unusual consistency, emerge rapidly after a long transitional period, and are framed within a chronology that places their origin before a catastrophic boundary event? Conventional scholarship has several approaches. First, developmental compression. Perhaps civilization developed much more rapidly than we typically assume. Given the right environmental conditions, agricultural surplus, population pressure, and trade opportunities, complex systems might emerge within a few centuries. The apparent completeness of early systems might result from incomplete archaeological sampling. We're seeing the end product, but missing earlier developmental stages that existed but haven't been found yet. This is possible. Archaeological preservation is imperfect. Much evidence has been lost to erosion, looting, reuse of building materials, and the simple fact that most ancient sites remain unexcavated. We're working with a fragmentary record that might not show the full picture. But developmental compression requires accepting that humans invented writing, mathematics, astronomy, organized medicine, systematic architecture, standardized measurements, and complex administration essentially simultaneously in a few generations. Then immediately standardize these systems across multiple cities without the typical period of regional variation and competing systems that characterizes other cultural developments. Second, transmission from elsewhere. Perhaps Sumerian knowledge came from other cultures that developed these systems earlier. Migration or trade brought ideas from Anatolia, the Iranian plateau, the Indus region, or undiscovered centers of development. The Sumerians implemented knowledge that was developed elsewhere, which is why it appears complete when it enters the Mesopotamian archaeological record. This is possible. Cultural diffusion is real. Knowledge does transfer between cultures, but we lack clear evidence for donor cultures with more advanced systems before 4000 BCE. The Anatolian and Iranian sites we've excavated don't show earlier writing or mathematics. The Indie civilization developed later than Sumer. Where is the source culture that possessed complete systems before the Sumerians is? Third, symbolic chronology. Perhaps the Sumerian King Lists' antediluvian numbers are not meant as literal chronology, but as symbolic statements about the mythic age before history began. The numbers represent sacred numerology, not actual years. The flood is not a specific historical event, but a metaphorical boundary between mythic time and historical time. This is the dominant scholarly interpretation. It preserves our chronological models while explaining why the Sumerian texts present impossible numbers. The Sumerians were not stupid or innumerate. They were using symbolic language in their historical texts while using practical language in their administrative texts. But this interpretation requires believing that the Sumerians maintained a symbolic chronology for 3,000 years, copying it faithfully, treating it as authoritative for legitimating kingship, yet never explaining that it was symbolic rather than literal. It requires accepting that the boundary event, the flood, was purely mythological, despite archaeological evidence of catastrophic flooding in Mesopotamian cities. Fourth, the Sumerian interpretation. Perhaps their explanation deserves consideration. Perhaps knowledge systems were developed before the Euro period, preserved through a catastrophic period, the flood remembered in multiple traditions and reapplied when conditions permitted. Perhaps the Ubaid period represents recovery after catastrophe rather than gradual development towards civilization. Perhaps what we call the origin of civilization is actually its restoration. This interpretation fits the textual claims, explains the completeness of early systems, accounts for the attribution to antediluvian sources, and provides a mechanism preservation through catastrophe for knowledge appearing largely formed. But it requires accepting that advanced civilization existed before our earliest evidence for it, and that knowledge was preserved across a gap we cannot clearly document. None of these explanations is fully satisfying. Each requires accepting something that troubles our understanding, developmental compression that seems impossibly rapid, transmission from source cultures we cannot identify, symbolic chronology maintained as literal history, or antediluvian civilization beyond our current evidence. The problem science doesn't solve is not whether ancient Mesopotamians were capable of civilization. They obviously were, as the archaeological record demonstrates. The problem is explaining where their knowledge came from, why it appears so complete so early, why they attributed it to transmitted teaching rather than local invention, and how to reconcile their chronological framework with ours. The Sumerian tablets present evidence, the archaeological sites provide context. The King List creates chronological problems. The knowledge systems function with suspicious completeness. The cultural self-standing points toward reception rather than invention, and modern explanations struggle to account for all these factors simultaneously without either dismissing significant evidence or accepting claims that exceed our models. What remains after evaluating these explanations is uncertainty. We cannot prove the Sumerians invented their knowledge systems rapidly and independently. We cannot prove they received them from other cultures whose evidence we haven't found. We cannot prove their chronology is purely symbolic. We cannot prove advanced civilization existed before our current evidence permits. What we can observe is the pattern knowledge appearing complete attributed to transmission preserved with dedication emerging after a gap framed within a chronology that places its origin before a boundary event marked as catastrophic. The problem science doesn't solve is not the existence of Sumerian civilization that is demonstrated beyond question. The problem is its origin, where the knowledge came from when it was developed, by whom it was transmitted, and why the Sumerians themselves consistently claimed it was given to them rather than invented by them. The tablets preserve the claim, the sites show the implementation, the chronology creates the problem, and the gaps remain. gaps in time, gaps in development, gaps between what we can explain and what the evidence presents, gaps between conventional models and the patterns the ancient text reveal. The question the tablets leave open. The sun sets over the Iraqi desert, casting long shadows across the ruins of Eridu. The temple mound rises from the sand, 18 layers of sacred memory buried within it, each maintaining alignment with the first, all preserving architecture established before cities existed, when kingship first descended and knowledge first came to earth. In museums across the world, clay tablets rest in climate-controlled cases. The Weld Blondel prism with its impossible chronology, the Eridu Genesis with its flood narrative and survival account, Plimpton 322 with its sophisticated mathematics, the Mole Apin astronomical tables, the Guardia cylinders with their revealed temple plans, the instructions of Shurapak with antediluvian wisdom, medical texts with comprehensive treatments, educational tablets from schools that taught the ancient. These are not mysteries in the sense of being incomprehensible. We can read the texts, we understand the mathematics, we recognize the astronomical observations. We excavate the temples. The Sumerians were real. Their civilization functioned. Their knowledge worked. The mystery lies not in what they achieved, but in where their achievements came from. The tablets function as answers to practical questions. How to calculate field areas, when to plant crops, how to treat wounds, how to build temples. But they also function as questions about knowledge origin, complete systems without visible development attributed to transmission rather than invention, preserved across catastrophes framed within chronologies that create gaps we cannot explain. You have heard the evidence. The King List with 2,400 years before the flood, the knowledge systems appearing largely complete when writing begins, the consistent attribution to divine teachers and antediluvian sages, the architectural principles maintained for 3 millennia, the mathematical sophistication functioning from the earliest records, the astronomical observations requiring institutional programs that predated our documentation of them, the medical knowledge showing competence without visible learning stages, the scribal schools teaching ancient texts as authoritative tradition, the Ubide to Uruk transition compressing too much development into too little time, the textual insistence on reception rather than invention. None of this proves the Sumerian explanation is literally accurate, that gods gave knowledge, that antediluvian sages taught humanity that civilization existed before the flood and was restored afterward. Proof requires more than textual claims and pattern recognition. It requires independent verification, archaeological confirmation, chronological frameworks that accommodate the claims. But neither can conventional explanations fully account for the patterns without requiring assumptions that exceed our evidence. Developmental compression happening impossibly fast. Transmission from cultures we cannot identify, symbolic chronology maintained as literal history, or knowledge appearing from nowhere through means we cannot specify. What the tablets leave open is the question of origin. They document implementation, they preserve knowledge, they record the claim that this knowledge was transmitted, but they cannot prove where it originated, whether it was invented rapidly in the centuries before writing, developed elsewhere and transferred through lost migrations, preserved across catastrophes from earlier civilizations, or given by teachers whose nature we can no longer determine. The question remains open because the evidence permits multiple interpretations. You can conclude the Sumerians rapidly invented, sophisticated systems that appeared complete because we're missing earlier developmental stages. You can conclude they received knowledge from other cultures whose archaeological remains we haven't found. You can conclude they preserve knowledge across catastrophic gaps from sources predating our current evidence. Each conclusion requires accepting some uncertainty, filling some gaps with assumption, choosing which evidence to emphasize and which to explain away. The responsible position is not certainty but informed uncertainty. The tablets reveal patterns that challenge our models. The archaeology shows transitions that happen faster than comfortable. The texts make claims that exceed our frameworks. The knowledge functions with completeness that suggests sources beyond immediate invention. Whether those sources were rapid local development, external transmission, preservation across catastrophes, or something our categories don't yet capture, that remains unknown. What is known is that Sumerian civilization possessed sophisticated knowledge, attributed that knowledge to transmitted teaching, preserved it with remarkable consistency, and framed its origin before a catastrophic boundary that divided antediluvian history from restoration afterward. Perhaps future archaeology will find earlier developmental stages that demonstrate local invention. Perhaps excavations in unexamined regions will reveal source cultures that transmitted knowledge to Mesopotamia. Perhaps better understanding of chronological systems will reconcile the King List numbers with our models. Perhaps analysis of preservation mechanisms will explain how knowledge appears complete without visible development. Or perhaps we will need to expand our models to accommodate possibilities we currently dismiss. That civilizational knowledge can be preserved across catastrophic gap, that cultural memory can maintain accurate traditions across millennia, that claims about antediluvian sources might point toward actual knowledge transmission from times and places our current archaeological record doesn't reach. The tablets do not demand a conclusion. They present evidence and preserve claims. They show what the Sumerians achieved and record what the Sumerians believed about where their achievements came from. They function as both answers and questions, answering practical problems while questioning our assumptions about how knowledge originates and how civilization develops. You have the evidence now. The impossible chronology, the complete systems, the consistent attribution, the preservation, dedication, the transitional gaps, the textual claims, the archaeological patterns, the knowledge that worked from the beginning. What you conclude is not predetermined by the evidence. Multiple interpretations remain viable. Multiple explanations remain possible. The question the tablets leave open is not what the Sumerians accomplished. That is documented beyond doubt. But where their knowledge came from and whether the gaps in our understanding reveal limits in our evidence or limits in our models. Perhaps civilization progresses steadily from simple to complex, and the Sumerian case fits this pattern despite appearing compressed. Perhaps knowledge develops locally through innovation, and attributions to external sources reflect cultural framing rather than historical fact. Perhaps chronological impossibilities are symbolic and flood narratives are metaphorical and teacher figures are mythological, and the patterns that trouble us arise from incomplete evidence rather than extraordinary origins. Or perhaps the tablets point towards something our frameworks struggle to accommodate. Knowledge preserved across gaps we don't expect, transmitted from sources we can't identify, maintained through catastrophes we underestimate, originating in times we can't reach with our current methods. The sun has set over Eridu, the museum cases are locked, the tablets rest in darkness, waiting for morning, waiting for readers, waiting for the questions they inspire and the answers they withhold. The temple layers sleep beneath the sand, each remembering the one below, all maintaining alignment with the first, preserving architecture that came from somewhere before the beginning we can document. The question remains open. The evidence stands. The gaps persist, and somewhere between what the tablets claim and what we can verify lies truth we have not yet reached. Truth about knowledge, origin, civilizational development, catastrophic memory, and whether human history progresses steadily forward or contains chapters we've forgotten how to read. If this investigation has resonated with you, if these questions seem worth pursuing, if the patterns revealed in these ancient texts trouble your assumptions or expand your curiosity, the tablets will remain where they have always been, waiting in their cases, holding their secrets, preserving their claims, leaving their questions open for those who come after, to consider, to weigh, to investigate further. The Sumerians gave us their answer. Knowledge descended. Kingship came from heaven. The sages taught, the flood divided history, civilization was restored, science gives us our answer, knowledge developed, humans invented, systems emerged through trial and error, myths encode metaphor, civilization progressed. Between these answers lies the space where questions live. The tablets occupy that space, neither proving the ancient claims nor settling into comfortable explanations. They preserve, they record, they testify, they leave open. Sleep comes now. If you need it, the tablets will wait. The questions will remain. And tomorrow, or sometime in your future, when you encounter writing or mathematics or astronomy or any knowledge system humanity uses, you might wonder for a moment, where did this come from? Who taught us? How do we know? The Sumerians asked those questions 4,000 years ago. They left their answers in clay. We read them still across gaps in time and understanding, across the flood of years that divides us from them, across the boundaries between their certainties and our doubts. The question remains open, that tablets remain patient, and the mystery of origin, where knowledge comes from, whether we invent or receive, whether we progress or remember, that mystery remains, waiting in the wedge-shaped marks, pressed into clay by hands that turned to dust before history began, preserved for us, passed forward through time, teaching still.